In this video, I'm going to talk about data collection in games. So, data collection in games is a systematic process of gathering information about like how the game goes, how your player experience the game, how the software performs, the legal stuff of it. So you need to basically collect the data to be able to process it and then understand how well your game is working. Um, in the modern game industry, there's no concept of finished game. You release it early, and then based on the data and information you collect, you basically change the game. The game evolves over time, and then it becomes closer and closer to what users basically expect and enjoy the game. Um, in games, we are collecting data. There are two different main categories of data that we collect. The first one is a quantitative, which is what is happening, and then qualitative, how the player feels type of data that we collect. Telemetry is the quantitative part of it. Feedback is a qualitative kind of section of that data that we are collecting. And then we also have the performance metrics that I'm going to talk about each one of them. So telemetry is basically is automated data sent from the game to the developer. It includes things like how many times a player died, which weapons they most use, where they quit the game. So things like that, they come to the developer automatically. So as a game designer, as a game developer, you need to create those type of systems in which you get some data from your users as they're playing the game. And then feedback or qualitative data is gathered through surveys, uh, through different posts in like direct play testing where player describe their emotional response to the game. So those are kind of another layer. They are not automatic. You need to go through and kind of interact with your users to get their feedback. And then performance metrics are technical data regarding frame rates, crash logs, loading time across different hardware configurations, and things like that. That again, they automatically comes to the developer. Again, as a game designer, as a game developer, you need to create those type of systems to make sure the data comes to you. Why it is important? So the first one is the game balancing and difficulty. So developer use data to ensure a game is fair. If telemetry shows that 80% of the players are failing a specific level, it is sign that the difficulty spike is too high. So you can use that data to make changes to your game. Uh, on the other hand, if everyone is using one specific overpowered weapon, data allows developers to weaken that item to keep the game competitive. So you can like use that to balance the the game and make sure the difficulty level is appropriate. The other aspect of why it is important is to improve user experience. So the data that you're collecting tells you where the UI is failing. If players are constantly opening and closing a menu without selecting anything, that data suggests the menu is confusing. So by tracking these kind of friction points as a game developer, as a game designer, you can streamline the interface and make it better for your players. The other one is monetization and retention. For free to play games, data is survival. It basically allows developers to track when and why players stop playing, what motivates a player to make their first in-game purchase. So you need to understand all of that, and that data allows you to make smart decisions. The other one is for bug identification. Instead of waiting for a player to report a bug, modern games they have like a crash report or log data that comes directly to the developer. This allows the dev team to see the exact line of code that failed and the hardware the player was using. And it makes it much easier to identify the problem first and then create a patch to fix it. Personalization is another reason why data collection is important. The data allows the game to adapt to the player to make it to help them to personalize it. Some games use data to adjust difficulty in real time, which is called dynamic difficulty adjustments, or to suggest new content and friends based on your social data and play style. So for all of that, we need to collect data to make our games much better. Um, so we talked about different type of data that we collect. One of them was the quantitative data that we collect. So we can break the quantitative data into more granular level. One of the data that we collect is behavioral data, which is the what and how. The behavior data is the most common form of game telemetry. It focuses on specific actions a player takes within the virtual environment that we created within that game. When I say virtual, it doesn't mean like virtual realities, the digital world. So the thing that we can track are things like death, item purchase, time is spent on a specific level, or even heat maps showing where players tend to get stuck. The purpose of all of that is it allows developers use this to balance the difficulty, which we talked about. If behavioral data shows the players die at the same boss, the developer might patch the game to make it slightly easier because if everyone goes there and like almost everyone dies, it makes players frustrated. So we use that to kind of evaluate that piece of the game and make changes, make adjustment to it. The social data, the who and with whom type of thing. As gaming becomes a social activity, there are so many games out there that you play with others. Tracking how players interact with other players becomes vital for retention. So the thing that you can track in those type of games are your friend list, chat logs, um, the memberships, gift sending habits. It also includes metadata like which games your friends are playing. The purpose of that is this help in building recommendation, and if a data shows your social circle is moving from one game to another, the system might suggest a new game to you to keep you within the ecosystem. The other type of data is biometric data, the internal response. This is more advanced and more research oriented form of data collection, and that is used to measure the physical impact of the game on a human. The thing that can be tracked, which requires a specialized equipment like galvanic skin response, which I do have two of them in my office. If anyone is interested, is like a it looks like a smartwatch, but it tracks lots of data regarding those like type of biometric that we need to understand and evaluate how people are kind of reacting as a human being. Like it measures sweat, it measures arousal levels. The other type of thing that we have in addition to that, we have eye tracking. You can look where exactly the player is looking on the screen. The galvanic skin sensors, they also kind of track heart rate, and it basically shows you the stress or excitement during high action sequences. The reason we do that is we often use them during playtesting phase to ensure, for instance, a horror game is actually scaring or a tutorial isn't too overwhelming to the player. The next type of data is the geolocation data, and that is the where. This bridges the gap between the digital and physical worlds, most notably in mobile gaming. So the thing that we track is the precise GPS coordinates and proximity to Wi-Fi beacons or general location based on IP addresses. And the purpose is in the location-based services, um, such as Pokemon Go, this is a core mechanic. For other games, it is used for regional pricing, language localizations, or targeted local events. All right. So now let's move on to game testing. Now we talked about like data collection, which you're using many of that when it comes to game testing. So game testing, often referred to as quality assurance, and that is a purpose of playing a video games to find and document bugs or any glitches to ensure the game is fun, functional, and balanced before it reaches the public. It includes a series of tests that encompasses every aspect of the application from its design and structures to performance and user experience. We use the data and feedback from those tests and we use them for bug fixes and improvements in general. And this is a iterative process. You collect data, you understand how your players are interacting and understanding your game, if they're enjoying it or not, and then based on that, you make changes. So the game testing starts with planning. Then you get into testing, bug reports and fixes, and final kind of release of that. This is an iterative process. This is not one way forward. You do this multiple times. And then every time you go back to the planning, testing, bug fixing, and go on and so on. So there are different types of game testing. We have game functionality testing and non-functionality testing. The the functionality testing, which is basically finding bugs, is the most traditional form of testing, and testers try to break the game by doing things that developers didn't expect. And just imagine, like, throughout the semester, you were involved so much with creating your own game, and it makes us blind to many of the problems that our games might have. Having others to go through that same experience and then hitting like dead ends and hitting problems or facing problems helps us as a game developers to go back and fix our games. When we do functionality testing, we look at different things such as collision testing and making sure the players doesn't fall through the floor or walk through the walls, for instance. We can test our save and load tests, have those save and load tests, making sure the progress isn't lost as a player goes through the game. Regression testing is another one, checking that fixing one bug didn't create it like another five different game like bugs in our games. So and because of that, it is iterative. When you do something, you need to go back and test it again. And then we do have non-functional testing, which are more on focus on the performance, scalability, usability type of things. One of them is the play testing to check the fun factor, and that is unlike the functional testing, the play testing or fun factor testing focuses on user experience. It answers the questions about is this game actually fun? So for the fun factor or play testing, we focus on difficulty balancing, identifying if a level is so hard or too easy that player either quit or gets bored. Flow state, checking if the game keeps the player engaged without being overwhelming or boring. Clarity, making sure the UI and instructions are easy to understand. So if we kind of go through all of that and they are all designed in a way that keep the user engaged, then we are kind of evoking that fun factor. The other non-functional testing that in the game industry is very common is compatibility and performance testing. And this ensures the game runs smoothly on various hardware configurations. One of the tests that is done apart from like testing in like having hardware diversity, testing on different type of devices, high, low end, like if you want to test it on low end smartphones versus high end PCs and also different types of PCs and smartphones. The other test that is commonly done and that is called soak testing, which is running a game for a long period, like 24 hours, to check for memory leaks or overheating. And then another non-functional testing that is done is compliance testing. And this is more on the legal side of testing. And you check it with the platform standards, making sure the game follows the specific rules set by different companies like Sony or Microsoft or Apple, and making sure you're not violating any of their specific rules. And then also localization, ensuring that the translated text fits within the box. Maybe in one language you have more words to describe certain things, so making sure everything fits within the design that you have. And then also cultural symbols that are not offensive in different regions. So you need to check for all of that, which makes the game testing fairly a difficult task. Um, so for the functional game testing, we want to get into the real world and understand the why behind each one of them. For the component module testing, it this is more of a micro level of testing, and developers check individual scripts or assets in isolation before they are part of the larger game. This type of testing is a single, like, example of that is a single health patch that we want to ensure is correctly added, for instance, 25 kind of value to the variables that we had without any other game system running. So we just test that module to make sure it is working. And this is often automated using unit tests. If the smallest part don't work, the whole system will eventually fail. The other one is integration testing, and this is testing how two or more modules work together. Example of that could be you test the health patch with the player character and see if both of them work together and if they are effective and create and do you have, like, for instance, an effective sound effect with it. um, this is where interface errors are found, where data being passed from one system to another get lost or corrupted. The next one is smoke testing. And this is a quick, shallow test to see if the game catches fire when you turn it on. If a build fails a smoke test, uh, it is sent back immediately, and you need to go back and make sure everything is checked. It basically saves time. There is no point in having quality assurance team spend like many hours testing your game when it crashes at the main menu. So you need to make sure it is all good before going to the quality assurance. Regression testing is retesting old features after a new update that was released to ensure nothing was accidentally broken. This is whack-a-mole of game development. This is essential for live service games like Fortnite or Legend of League of Legends that receive frequent updates. The other one is localization testing, and that is to ensure the game feels native to different regions. This also includes culturalization. So localization and culturalizations are kind of they like go hand to hand with each other because some of them are related to language and some of that is related to the culture. And I used to check the colors, symbols, gestures, and making sure they are not offensive or misunderstood in different parts of the world. And then last one is the security and access control. And that is to protect the game from hackers and ensuring players only see what they are supposed to see. And in modern gaming, this is vital for protecting user data and maintaining the integrity of competitive leaderboards. All right, so for the non-functional game testing, um, so the functional testing asks, does this feature work? Non-functional testing asks, how well does this feature works, or what is the player experience like? And it focuses on seven different kind of aspects when it comes to non-functional games, which we talked about very briefly a couple of slides ago. The first one is performance. That is stability and responsiveness under normal conditions, like checking the frame rates, battery consumptions, latency on multiplayer games. So a game might be bug free, but if it runs at 10 frame per second, it is unplayable. Performance testing ensures the game feels smooth. The next one is load and stress. Um, the focus is finding the breaking point of the system. Um, the load testing checks if the game handles the expected number of users. So if you have maybe two users or 10,000 users, you need to check that. So stress testing pushes it until it crashes. And it could be example of like you have 1 million, you start with 10,000, and then as soon as it gets to the million user, you see it start failing. And then example of that is a day one launch for an MMO where thousands of players try to log at the same moment, and you want to see if that kind of causes any issues. The next one is installation, the first and last impression that you are going to have on your game. So it's checking the installer, the uninstaller, and how the game handles updates. It also covers cloud saves, ensures that if you save on a console, you can pick up where you left off on a PC. So if the installation process is frustrating or takes up more disk space than advertised, many users will request a refund immediately. The next non-functional game testing is usability, and that is the human-centered or human-computer interaction aspect of it, and also the accessibility. And it kind of answers the questions of, can the player navigate the menu? Are the controls intuitive? So it's more about usability and what they're experiencing. So this is also where you test accessibility features such as color blind mode, button remapping, screen reader support. And okay, the next one is recovery. The recovery is more about graceful failure. So what happens if the power goes out, the Wi-Fi drops, or the game crashes during a boss fight? So the goal is the game should be able to recover data and return the player to a functional state without corrupting the save file. The next one is compliance, and focus is on the legal and platform specific requirements. Different companies like Sony, Microsoft, Nintendo have a strict technical requirement checklist, and as a game developer, game designer, you need to make sure you are complying with their requirements. Configuration is puts the focus on hardware and software diversity. And the challenge is, unlike console games, PC have thousands of combinations of CPUs, GPUs, and RAM that you need to kind of pay attention to. All right. So, going through that data collection and game testing, now you need to think about what kind of game testing you want to use for your specific game. Think about the game testing you have done before, um, either on purpose or just going through some of the experiences that player went through. Maybe you reported a bug to a company. So think about all of that and think about how your game is going to go through that same process, how you're going to make it, like, go through the functional testing and then non-functional testing, and making sure you have enough data to be able to validate and have that iterative process of mm, going back and making your game better. So there are different stages of game testing. You start with a test, you collect feedback, you test again after you made improvement. So before you kind of go back and test again, you make adjustment between these two. So you get feedback, make modification, you test it again. So this part is like you repeat it as necessary. Test, get feedback, make changes. Test, feedback, make changes. Until it is at the stage that is playable, there are small things that you can make changes over time. This is like a nice video of like game testing that I recommend to watch.